But let's look at some of the main points we're trying to get at here. Is drought and variability are a large part of the driver that we deal with out here in the plains. We're in the middle of the North American continent, so we deal with what we call continentality. Basically, we're in the middle of the continent, so we are extremely variable. That's why we warm up in the summertime, we get cold in the wintertime. Plus, there are other ideas of variability that we'll talk about here briefly. You know, the thing we're trying to get at, and our pointer apparently is not working, so is that idea of soybean yield change, and this is not working, so we'll go this route. Variability issues. Variability has existed and will continue to exist. We'll talk about the climate change. We're going to try to touch on climate change real quickly at the end of this to put some context on this. Droughts will continue to occur. That was one of the lessons we learned from this last summer, is that drought is part of the cycle here, and that Dust Bowl level, Corn Belt wide droughts can and will still happen. We hadn't had one in 24 or 25 years since 1988. We kind of lost that thought that it can happen, and it will. It will continue to happen. Is it going to happen this year? Well, that's another conversation we can have, but that's still going to be part of it. The other idea about variability is it has shown some potential for worsening. And that is one of the things that is projected with potential climate change, is that not only are we going to have our existing variability, but we're going to get widening variability. We could get more in-season and between-season variability just to add to the fun of agricultural production. Just because you guys don't have enough to deal with, we're going to throw another level of variability on there just to have fun, and it keeps us in business, okay? So, it does obviously present serious management issues, and it does need to be better understood, okay? Part of the problem that we deal with is that, you know, that there's a lot of modeling and forecasting goes on, you know, on a day, you know, week basis, and there's work going on. We're talking, you know, 50, 100 years out in the future with climate change issues. Not as much is happening in that seasonal to interannual, one season to the next. And we've had opportunities to be able to make that conversation to people and say we need to do more with that, because there are a lot of agronomic decisions that are done on the 1 to 5 year time scale where we don't have a whole lot of people, we don't have a whole lot of information to give them. Okay, another map here from a great agronomic journal called the New York Times. Actually, probably one that some of you may have seen already, but it's an impressive picture to show. What this does is somebody from the New York Times went back and looked at how much of the U.S. was covered by drought in June. And the top row is 2012, is 2012, 11, and 10. And we looked back longingly on 2010 when we actually had water in South Dakota, and we wanted to get rid of some of it. The 2000s, 90s, 80s. So I pointed out some years that would be comparable in coverage to where we were this year. And it is interesting to look at the variability that does happen, because you look back at 88, we compare to years in the 50s where we had widespread droughts, maybe not quite as severe as some of the other ones, but they still were very widespread, and then of course those back in the 30s. And I guess the year one is 76, 77 that a lot of people keep reminding me of here, that I was in Iowa in 88, so that's what I refer to. People here go, no, not 88, 76 was the one around here that we have to. So we know that there is this variability that exists. Some of it we can describe and explain, some of it we cannot describe and explain. Now, since we've talked about that, let's bop past this. If we look at this even from a longer context, we have a little over 100 years, about 120 years of good data across our area. If we want to look back farther, we have to look at other proxy data that help us understand more about the climate. One of these is tree ring reconstructions using the Palmer Drought Severity Index. There's been quite a bit of work done relating the Palmer Index, the long-term drought indexes, to the sizes of tree rings. You know, it's not a perfect predictor, but it does give us a pretty good idea of where we are in the way of long-term variability. Here you go back, and the plot on the bottom is the number of tree rings that were available, and you see as you go back before 1600, the number of tree rings available is not very large, so it becomes a little bit more tough to deal with. But it is still as interesting to look at the top, and what we're looking at there is from about 2000 back to the year 1200. The higher the number is, the wetter it is. The lower the number is, the drier it is. And I wish I had the pointer here, but if you look and compare. Ah, we can do that. Thank you. Oh, okay. Thank you, Yeba. Okay, here's where we were in the 1930s. Look at where we have been under some previous years. So if you compare where we were this year, this past year was similar to any one of the worst years in the 1930s. The only thing was in the 1930s you had about 3 years out of 6 or 7 that were this level. But then you compare this going further back, and there are some longer periods and worse periods in the Dust Bowl, just to get you depressed on a day like today. But it's a reality we have to face, and we have to understand that that exists here. They don't come around frequently, but they do. And I'm not necessarily calling for that now, but it's something we need to understand as part of our variability and understanding of drought in our area. On the off side, where we would have been the last few years would be up similar or even higher than some of these higher levels here. That's how excessively wet we were. And that's another idea of understanding that variability. We have gone from some of the wettest we have ever seen to some of the driest we've ever seen in a 2-year period. That's a monster shift. Okay? We're not going to dive into these too much. There are certain variabilities and certain parts of the variability in climate that we understand. ENSO refers to El Nino, La Nina. That's a variability we understand. The PDO is an atmospheric shift. We'll talk about this one in the Pacific. This one is in the Atlantic. And there are some other ones here that are related that we won't dive into too much. But these are some of the known variabilities, some of the things that we can relate to understand why the climate varies, some of the interannual variabilities. But note that for all these things we know, we still can explain like about 30 or 40% of the variability from one year to the next. And that's part of our problem, is understanding how those shifts occur from one year to the next and what keeps us busy in trying to understand what happens from one to the next. Here's El Nino. The area we're talking about is in the Pacific Ocean. The biggest part of El Nino and La Nina is in the wintertime, but a couple things we do know is typically El Nino summers, if they happen during the summer, tend to be not bad growing seasons. La Nina, the opposite phase, tends to be not good growing seasons. Neither one of those is going to impact us this year from that standpoint. The second one is the Pacific Decadal Oscillation. We're talking here about shifts in sea surface temperatures. Here's North America here, shifting between large areas of colder water to larger areas of warmer water in the northern Pacific. Whereas El Nino, La Nina is something that changes on the order of a year, every couple years. This shifts, because of the name decadal, on the order of every 20 or 30 years. There are certain variabilities in it, but it changes on a longer term time scale. Then we are also understanding that there is interaction that occurs between these different sea surface temperatures. This is a paper that was done actually about 10 years ago, but it's picked up a couple of press right now, that this is the current phase we are in right now, between looking at the PDO, what's happening in the Pacific, and what's happening in the Atlantic, indicating that the red areas have increased chances of drought and blue areas have decreased chances of drought during this combination phase that we are in right now. So noting that we should still be in somewhat of a wetter phase according to this, but note that a large part of the Corn Belt and areas to our west and areas to the south specifically, and this one's shown up really well, should be that way. After about 2020, according to this paper, we go into a larger area of increased drought possibilities. Okay, now this is one paper, this is one idea of variability. There's lots more we have to understand, but we are understanding more about how these changes, longer scale changes in sea surface temperatures, really get at some of this interannual variability and explaining some of these things that happen. Okay, that's just to talk to you about that there is variability, some of the things we understand, some of the things we don't understand about variability. Okay, let's look at some of the current trends that we're dealing with right now of part of this variability, because those are also part of understanding where I am. This is changes in precipitation for South Dakota from 1895 to 2010, Iowa, and Indiana. The idea getting at, there's a lot of variability again in the annual, this is annual precipitation, but all across the upper Midwest, despite what we've seen last year, we're still in increasing precipitation. More precipitation is occurring. And that is leading to some other interesting variabilities that we'll talk about. Part of that has been time of year, large changes in time of year of precipitation. Unlike the last 2 years, Chris Hay is here. Where is Chris? Chris took off. A plot that Chris made, so I've gotten a lot of mileage out of this, Chris. Thank you very much. Thank you. So we'll make sure in your tenure packet that we put that on there. Okay, changes in fall precipitation. Unlike the last 2 years where we've been extremely dry, the previous part of that had been lots of increases in fall precipitation. So part of it is time of year, but overall increases in precipitation. More precipitation days. This is data from Iowa showing numbers of days for different times of the year. Nearly all times of year seeing more days of precipitation. And then probably another bigger one to deal with from a soybean perspective is not only additional precipitation, but higher dew points. For those of you not familiar with this, dew point is a raw measure of the amount of moisture in the air. Higher dew points are leading to a couple other issues. Okay, if you've got higher dew points, what does that do to your overnight temperatures? Your overnight temperatures increase. You increase your overnight temperatures, you got more moisture around, what does that do to your dew formation? More dew, longer period of time. Now, I have not seen specific data on this, but anecdotally when I talk with people, that seems to be coming up that, yeah, there's some disease, we may be seeing some more disease issues. Now, obviously the last year or so, last year there was not nearly the amount of moisture in the air, but the overall trend, and this is Des Moines, St. Louis, Kansas City, all across the upper Midwest, we've been seeing increasing amounts of moisture in the air. It also presents problems with, we've seen it especially in corn, across the southern part of the Corn Belt. The moisture in the air increases your overnight temperatures. So we've not seen as much of it up here, but the further south you've gone, more nighttime temperatures that have been very high. And high overnight temperatures have also caused problems with stress in corn and reductions in corn yield across particularly the southern part of the Corn Belt. And that is shown up here. A plot across North America of days with unusually warm daily low temperatures, overnight temperatures, lots of increases in overnight temperatures, producing very high heat stress indications. Some of the other trends, I guess overall trends to look at, our biggest trend in the way of atmospheric conditions, in addition to precipitation, is wintertime temperatures, warming wintertime temperatures, which has led to fairly nice overnight conditions, but it induces a couple other issues along with that. Obviously, warm winters, and I don't have a slide on this, we've seen longer growing seasons, a longer period between the average first and last freeze, so that's been a positive, but likely we're seeing some insect issues because of less killing off of insects as we go along because of the warmer overwintering temperatures. From a summertime standpoint, our summertime temperature trend has been relatively flat. White areas are flat, blue is actually a little cooler, yellow is a little bit warmer, but again, more precipitation showing up in our summertime. Okay, one last thing we got to talk about too, and this is not an issue of happening tomorrow. This is something as time goes along, is the issue of climate change. It is another issue, another add-on to our level of variability, is that we can not only rely on what has happened previously as an understanding of what's going forward, but because of the greenhouse gases, we're seeing changes in climate going forward that are going to change our issues. I've talked about the variability also, but we need to talk at least a couple about some of these issues going ahead. What we're showing you here is a bunch of different climate models, and I think this is at about 50 years, showing the changes in temperature. There is no one model that predicts everything perfectly. So what you do is you run different models and compare them and say, do you get the same answer from the models? So looking at this, you do see consistency that every place, and the darker red it is, the more warming we're going to see. That's been a consistent message. Some variability in the models, but here's the mean right here. The mean of the models says, especially within the continental U.S., we're going to warm overall. Okay? From an agricultural perspective, there's pluses, there's going to be winners and losers. With climate change, there's going to be winners and losers. Likely the further south you are in the Corn Belt, the further south you are in the plains, tougher time it's going to be. Depending on what happens with precipitation, we might be a net winner. It is possible we could be a net winner out of this. Now, I'm not saying we got to go continue and try to push the climate changes more, but I'm saying there are going to be changes that happen. the biggest driver for us and the biggest thing for us, what's going to happen is in the way of precipitation. So this is those same set of models again, the mean right here, some variability in them. The general answer is areas to our south get drier, areas to here and to the north get wetter. Okay? So if we do get wetter overall, we could offset some of that potential change in temperature, but the downsides are variability is going to continue, potentially get worse, and a large part of this precipitation is going to come in bigger rainfall events. And if that does happen, that's a problem for us because then it becomes less effective precipitation. So that is a big driver in this overall issue. And that has been noted by other reports that have come out. Changes in the frost-free length, longer seasons, fewer frost days, more hot nights, and reduced numbers of dry days up here, more dry days further to the south. And one other piece, since I'm running low on time here, obviously it's not only about the climate. There are other changes that occur. If you change, you change pollinators. If you change when something blooms and you change the pollinators, that's a downside. It's going to change water. And this is the one that again, there will be positives from some plants that react to CO2. There are also some negatives from this, and this is the one that shook me up. This is from an ARS scientist I was on a panel with about a year and a half ago. You weed guys, I'm not sure what that is. This is under current CO2 conditions and current herbicide rates. That's doubled CO2 conditions and 4 times the current herbicide rate. Doesn't touch the weed. Those are the kind of things that are going to happen. Climate changes or not, these kinds of things are going to change and things we have to deal with. So, well, one more map for you current. Here's our current drought monitor map. Just we can talk a little bit more about this afternoon too. Eastern Corn Belt has recovered from drought. We have lots of recovery we have to do at this point as we go along into the year. Okay, and we'll skip the other parts. That's where you can find me.